All right. Hope everyone at home is safe and comfy and warm and snuggling up with your favorite blanket or next to a fire or with your favorite video game. I'm currently downloading Wartime or the new Call of Duty thing. I've been playing Battlefield 5 Firestorm constantly, so this new Warzone looks real interesting. Plus, it's free, so I know Mr. Mead and I are going to try and hit it up today or tomorrow. So, what we're going to work on this week is going to be creating gears in Fusion that when we get back to school, everybody will be able to create their own gearbox using their Fusion model and laser it, cutting it out like their airplane or any other Fusion model you can create in 2 dimensions. So I'm going to first talk to you guys about what is a gear ratio, what's a gear train, and a compound gear system. First, you're going to understand everything about a gear and how to calculate their ratio. Then you guys will do some calculations, and then on Wednesday we'll move into actually creating gears in Fusion. Okay? So, without further ado, gears are mechanisms that they're also called spurs. Basically, what they do is you have 2 sizes, and they spin in opposite rotations. So, if you look at the silver gear down here, if this was my motor, so let's say I have a motor right here, it's spinning this one, let's say, clockwise. Okay, then this one, when this tooth hits this tooth, this gear, this gold gear, will be spinning in the opposite direction. Not only that, but you're actually gaining power or losing power based on the size of your input gear and your output gear. Okay, and that's what we're going to talk about today. Gears that mate and turn in opposite directions. So like I said before, if one is turning clockwise, the one touching it will be turning counterclockwise. You can think of this as positive times negative. If I have a positive, it's going to be going the opposite direction, or negative if I multiply them together. That comes into play when we start looking at idle gears or longer gear trains than just 2. So this gear train, right, has 2 gears. This gear train has 3 gears. Now, if you have an even amount of gears, your last gear will always be going the opposite direction. If you have an odd amount of gears, your last gear will be going in the same direction as your input gear. Because my input gear is going clockwise, my idle gear is going counterclockwise, which means that these two, my idle gear, what that mill in the middle is called, or this gear on the end. Okay? Hi, sweetheart. Of course you can sit with me. You want to learn about gear ratios too? Let's do it. So this middle gear, sweetheart, is called an idle gear. Can you see idle gear? Idle gear. Good job. Okay, and this gear is turning the opposite direction of the one touching it, right? Okay, so if I had 5 gears, let's say I had 5 arbitrary gears, right, and this is my input and this is my output, all 3 of these are called what? What are they called, sweetheart? Idle gears, that's right. Can you say idle gears? Idle gears. Yeah, and they don't change anything to do with the gear ratio at all. In fact, they really just cancel. Yeah, that's a big piece of bread, huh? Why? Because I made it in the air fryer. I didn't know what I was doing, so. I know, eat that big bread. I do. Do you like it? Is it yummy? Mm-hmm. Good job. All right, so these really just cancel out. I want the one. Hey, maybe I gotta finish this, okay? All right, so these idle gears cancel out, and then my gear ratio will be between my input gear, whatever value that is, and my output gear, whatever value that would be. So let's look at those. We're not going to talk about RPMs and torque values for these gears. We're really just going to talk about the size of them, either the diameter of the gear or the number of teeth the gear has. Okay, but there's also a way to calculate them using the torque that is going into the gear or the RPM that is coming out of the gear or into the gear. So that is to say how much force is being applied to the gear or how fast the gear is turning. We're not going to talk about this in this lesson. We're only going to focus on diameter and number of teeth to make your life a little easier. Okay, so again, variables to know. We need to know number of teeth and diameter. We're not going to look at angular velocity or torque, though you could if you wanted to. So all of these values we're going to ignore. for now. They would come up with the exact same gear ratios, all 4 of them together. No, kiddo, I have to do it. So, yeah, so we're not going to focus on torque or RPMs. We're only going to focus on size of gears because we haven't gotten into measuring RPMs or torque. So, N refers to the number of teeth in a gear. So in this gear, you can literally just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a 12-tooth gear. And this one, 1, 2, 3, 4, 5, 6, is a 6-tooth gear. And we see that right here in this equation. All right? And then the diameter, we could measure it, okay? Or it actually gives it to us right here. This diameter, again, this is the symbol for diameter, okay? Call it in. This diameter is 4 inches, or 4 inches. And this diameter, so we'll call this diameter out, diameter in, because this is being declared as the input. That's what the motor would be on. And this is the output, what the wheel would be on, or whatever mechanism you want. The diameter here would be 2 inches. Okay? So far, so good? And that would be this variable. Again, we're not going to focus on the torque or the RPM. So, just using number of teeth and diameter, let's figure out how to do this. Now, the gear ratio is going to be exactly the same no matter how you calculate it. Okay, if I calculate it using number of teeth, or if I calculate it using the diameter, it's going to come out to be exactly the same. Hopefully you can see that already. But if you can't, we're going to go ahead and get into this. So the gear ratio is any number over 1. We're going to simplify it down to a decimal. Okay, so if we take the number of teeth in our output gear and divide it by the number of teeth in our input gear, we get 12 over 6. Right? Remember, the output was assigned to us. Now, if we were making our own system, we would have had observed where we put the motor on. So we would have known the motor goes right here, and then this is going to be on the wheel or some other mechanism that is an arm or something, right? But since we didn't build this system, they had to go ahead and tell us what the out and the in was. So this little red gear is my input, and this big blue gear is my output, because it told me. All right, so that gives us a gear ratio of 12 over 6. If we use the diameter, it would be 4 over 2. Now notice that something really interesting happens with the units. Inches over inches cancel out. And I'm left with no unit at all. Right? If this was 12 teeth over 6 teeth, those also cancel. I'm again left with no unit at all. That's important for gear ratios. Gear ratios do not have a unit. It is simply a ratio. Okay, it's a number that relates two things together. There is no unit for ratios. Okay, so the gear ratio for this system would be 2 to 1, no matter how you slice it, 2 to 1. Okay, so remember what I told you before when we have long gear trains, because this gear train is only 2. This gear train has 4 gears, right? So we need to figure out which one is which. Okay, so looks like this is my input and this is my output. It didn't tell me, but I'm going to go ahead and make that assertion. So my input gear, we're going to go ahead, wait. Ouch. No, I lied. This is my input and this is my output. Okay, so we're going to go ahead and calculate these two between A and B, and then we're going to calculate the gear ratio between C and D and see what happens. Just to prove to you that those two gears, B and C, have nothing to do with the gear ratio. Okay? So the first gear ratio between A and B is going to be output over input, which is 12 over 20, so 0.6. Okay? So you could just write this as 0.6 gear ratio. Now, the gear ratio between B and C, okay? Remember, if this was my input, this is my output, but now my output gear is, in fact, an input gear to C, okay? So, again, the gear ratio is going to be 5 over 12, or 0.42, okay? And last but not least, since power is coming out of here, this is now an input to my output, 20 over 5, which is 4 to 1, okay? So 4. So the total gear ratio here is we're going to take all three of those values and multiply them together. Okay? We're going to take 0.6, which was A to B. We're going to take, or I'll call it B to C, or B to A. This one, which was C to B, and this one, which was D to C. We'll take them and we multiply them all together. That's how you deal with compound systems. So we're going to multiply them all together, and I'm going to get 1 to 1. So if I was just to take A over D, I would have gotten 20 over 20, which is 1. If the last gear had 40 teeth, what would the total gear ratio here be? So if this wasn't 20 teeth, if this was 40, and nothing else changed, what would be the gear ratio here? Well, nothing else matters. I don't care about these two. I'm just going to take the output gear at the end of my train, which is D, and put it over the input gear of my of the input gear at the beginning of my train, and which is A, number of teeth, which is equal to 40 over 20, which is 2. It doesn't matter what the idle gears are. Anything in between those gears does not matter to my gear ratio. All they do is move my motion down the train. Okay? What matters is where I put the motor, which in this case was A, and where I put my wheel or mechanism, which in this case was D. Okay? So again, if I was to do the math between A and B, multiplying all together, you get the same thing as I got. Boom. All right, compound gear trains. Compound gear trains, like we just did here, right? You take one gear ratio and you multiply it by the next one. The difference is wherever I have 2, that is my compound. So you see how I have one shaft with 2 gears, the yellow and the blue? That is where my compound takes place. So I'm going to have 2 gear ratios. The red and the blue, okay, this one, and the yellow and the green. Then I'm going to take those gear ratios and I'm going to multiply them together like I just did. But this time there is no train. There are 2 separate gear systems. Thanks, kiddo. I love crackers. There are 2 separate gear systems. Okay? So, the 2 middle gears share a common axle. That's the yellow and the blue. So they rotate at the same speed. They have to. See how the dots are the same? Never changing. This allows the final gear to rotate slower and produce more torque if they were connected only by the driven gear. So, if I had this, what's the gear ratio between A and B? A and B would be, so A is my input, okay? And B is my output in this case. So I'm going to take my output over my input and get 40 over 10. So my gear ratio between A and B is 4. Gear ratio between C and D, since motion is being transferred to B, B becomes my input for the next system. And my output now is, C is now my input because they share the same axle. When B turns, so does C. C is my input for D is my output gear. So I would take 50 over 20, okay, because 50 for my output gear, 20 for my input gear, which is C. And I get 2.5. I'm just going to simply multiply both those gear ratios together. C and D times AB, and I get 4 times 2.5, which is 10. So this compound gear ratio is 10. So your assignment for today is to calculate all of these gear ratios, okay? I'm going to tell you this is input, okay? And then this is going to be my input, which means this is output and this is output. So we'll go ahead and do the first one together. Thanks, Mr. Eversole, you're the best. I know. This e-learning is really working out for me, guys. You guys are so nice. All right, so the first thing I got to do is figure out for ratio number 1, I'm going to take AB, and I'm going to find DC. I'm going to multiply them together to get my compound. So step 1, let's find the gear ratio for AB. I'm going to take my output, which is 50, and divide it by my input, which is 14. So 50 divided by 14 is 3.5, we'll call it 7, okay? To 1, but 3.57 for now is fine. CD, same, output over input, which is 40 divided by 24 is 1.6. Now, all I gotta do is take both those values and multiply them together. So I'm gonna get 3.57 times 1.66, oops, not that, times 50, no, let's just do this, times 3.57. I'm going to get 5.95. So my compound gear ratio for this system is 5.95. Your assignment is to come up with the gear ratio for B to A and D to C and the compound gear ratio for the rest of these systems. Okay? So you have 4 you have to do on your own. I've given you the first one as an example, and you have to come up with them on your own. So if you have any questions, go ahead and email me at debersol, like that, and then careeracademysb.com. Okay? You guys should have it already. If you have any questions, let me know. Happy quarantine, guys. I'm done.